on the left. Consider this function, and we're going to show you what it looks like on Desmos. This function models the path of a river. The river you can see on the diagram as a dotted line, where both axes represent distance and are measured in kilometres on the same map. The location of a highway, which is the solid line, is defined by the following function, which is g of x. So now you can see that our diagram on the right matches the diagram on the left. The origin 0, 0, which is just where the two axes cross, is a location of the centre of a town called Orangutan. A straight footpath P is built to connect the centre of Orangutan to the river at the point where x equals 1/2. So you really need to understand what this question is asking. Let me show you on this diagram what I mean by this. So if we wrote down x is equal to 1/2, the straight footpath P is built to connect 0, 0, which is where Orangutan is, with the point x equals 1/2. So rather than drawing a line using the equations, I'm going to draw a line physically on this diagram to show you what this means. So this is what the straight path is going to look like, and you can see it varies and starts at 0 for the x-axis, and then its final value where the path ends is at 1/2. So the question here is very simple. It says state the domain of P. Now the domain of P is simply the x values of this footpath. So if we have a look at this question here, we can see that the domain of P simply is 0 is less than x, which is less than 1/2. So x is represented by an inequality, and the domain is always an inequality between two different numbers, or it can be an inequality with just one number, such as if x was bigger than 7. The next question, bridges are located where the highway crosses the river. A straight road is built from the centre of Orangutan due north, so due north means just up the page, to connect the town to the highway. Find the distance from, again, Orangutan to the point at which the road meets the highway. So this time, rather than looking at x equals 0.5, we're going to look at x equals 0. And all we want to do is find where these two cross. Using Desmos, this is really straightforward, but in D1 and D2, the way you'd have to do this is work out when this blue graph has x equal to 0. So what you would do is you take this equation and you'd substitute x is equal to 0. This is for the question, which is talking about a path going from Orangutan up to the highway. And the reason why we're substituting x is 0, as you can see with this green line, x is always 0. So checking out the mark scheme, we've got the following. When we take the function which is to do with the highway, we're just going to simply substitute in 0. And you can see that when you substitute anything to the power of 0, it should always equal 1. So it's going to be 0.5 times 1 plus 1, which is 1.5. Let's go on to question C. This straight road crosses the highway and then carries on due north. So what we mean by this is the straight road, the green line, and it's going to touch the blue line, and the blue line is the highway, and then it continues north. Now the red line, remember, is going to be called the river. And you can see vaguely from this image what's happening with the river. It says state whether the straight road, which is our green line, will ever cross the river. So the way you answer this is you can see that the red line is approaching the green line, so the river is approaching the road, but they never actually touch. So we can say that the asymptote of the river is x equals 0, so therefore they would never touch. The exact wording for this in the exam can be written in a multitude of ways, but basically you need to use the word asymptotic or asymptote and you need to allude to the x equals 0. It's not like some courses where you need to have really exact answers. So let's have a look now at a slightly different question. Let's have a look at question 14. This says it's describing what's going on in this particular diagram here, and it's got different points identified. For this particular question, you don't really need to read it because the actual punchline to the question is at the bottom. Write down the range of f. So the range of f is completely different to the domain because this time we're focusing on the y value. So you can see that this function varies between 0 and 6. So all we do is we write an inequality between 0 and 6. I'm going to show you the answer now. So looking at our mark scheme, we have question 14 will be on the screen very shortly. We know this function is f of x, and we're going to say that the range of f is between 0 and 6, and it includes the 0 because it actually touches the x-axis, and it includes 6 because it actually touches that point where 6 is. Now we're going to go over the final question, which is going to be question 20. Elvis Presley is a popular singer, and the number of impersonators is modelled by this particular function. So let's type this function. You should realise that this function is exponential because we have a function or a letter equal to a number times another number to the power of a letter. When it's to a power of a letter, it's always considered as an exponential function. So rather than writing t, because we're working with Desmos, and this is the same when you're working with your calculator, write to the power of x. So if I zoom out, I can see the function is here, which is brilliant. And it says where t is the number of years since 1977. So write down the number of Elvis impersonators in 1977. We know that this axis here, if we write down x is equal to 1, that would be the number of Elvis impersonators in 1978, where these two graphs intersect. And then if we wrote x is equal to 2, this would be the number of Elvis impersonators in 1979. If you want to be able to see more of the graph, what we're going to say is we want to see a lot less of the x-axis. So we're going to change this to be 20 or 10 as the maximum because it was too zoomed out. I'm even going to change it possibly to 5. Now we want to see less of the y-axis or more of the y-axis because we can't see too much at the moment. So let's change this to 200 and see if this is helping. This is much better now. So you can see here, if we click this number, in 1 year after 1977, there were about 222 Elvis impersonators. And then the following year, we're going to get 291. So you can see it's exponentially increasing. So to answer the question, write down the number of Elvis impersonators in 1977. We know that's got to be at the start of the time period where t is equal to 0. So what you would do is you just put x is equal to 0 or t is equal to 0. You find where they intersect. You can see it's 170. There's 2 more ways you can do this. What you can do is you can take the equation itself and you can substitute t for 0. So you would write down 170 times 1.31 to the power of 0. And we know that anything to the power of 0 is going to be 1. So 170 plus 1 is 171. Another way we could do this is by thinking about where we are going to get a y-intercept. And the y-intercept of an exponential function is defined as follows. If we've got a times b c to the power of t, there's a special method of working out what is going to be the y-intercept. So the y-intercept here is 171. Let's have a think about where we've got the 171 from. I'm going to do this by changing the function very slightly. Let's now change it to 170 times 2 times 1.3 to the power of x, and let's see how this changes. Okay, so we've now got a y-intercept of 340. And this is because we've times it by 2, so actually this number here changes to 340. Let's go back to the original function, which was 170 times 1.31 to the power of x. You can see that the y-intercept simply is the number on its own or the a. So if we were thinking about y equals ab to the power of x plus c, the y-intercept is always a and the asymptote of the graph is always a plus c. So for part B, calculate the time taken for the number of Elvis impersonators to reach 130 with the 3 zeros at the end. So what you would do is you say, is this on the x or the y-axis? This is going to be on the y-axis. So we are going to type this number in, check it is correct. We have got 4 zeros. This also says 4 zeros. We're going to zoom out and we're going to see when this happens. At the moment, we can't see enough of the graph. And it might be because I've made a potential mistake, but I don't think I have. The quickest way of doing this would be to change the settings, and we're going to change the y-axis to 140,000. And you can see now that we can see the answer. So if you click here, you can see that after 24.5 years, this is when we get to this many Elvis impersonators. And if we have a look at the answer to question 20, let's double check our first two answers. 20A, we did have 170, and you can see that the answer here is going to be 24.6 years, and you can see this here, 24.588. There are other ways you can do this, such as using logs, but this is the easiest way to do it in M5. Have a look at part C now. Calculate the number of Elvis impersonators when t is equal to 70. So very similar to the previous question, but this time we're just going to write x is 70 rather than y. So x is 70, but now we can see too much of the y, so we're going to make sure that's a lot smaller, the number. Let's change it to 100. And we want to see where these two intersect. So I still can't quite see enough because we've got too much x and not enough y. So let's narrow the x-axis to 5 like we had before. And we want to see where they cross. We still can't see where they cross, so we need to make the y-axis a lot bigger. Let's make it double as big. $50,000. And you can see it keeps going for a very long time. So you'd have to keep scrolling up this graph or changing the window. Let's change this to 100,000, see if this is any better. Or 1 million. We're not quite getting there with this answer. So you can see that this is a bit of a difficult way to do this question. So the best thing to do for this question, because we're finding what the y value is just to substitute what the x value is. So wherever there's an x, you're going to replace it with 70. So we get y is equal to 170 times 1.31 times to the power of 70. And we just simply put that on our calculator, and the following answer we're going to get is going to be part C, and we're going to get an incredibly big function. You can see here it's going to be 27,500,000,000. That's unlikely to be in the exam as that number is so ridiculously big. It says the world population in 2047 is projected to be this amount of people. Use this information to explain why the model for the number of Elvis impersonators is unrealistic. So what we need to have a think about is 2047. How many years is that after 1977? Hopefully you can work that out. That's 70 years after. So if we substitute in 70 like we did in the previous question, and we've realised that the answer to the previous question is 27 billion, you can see the answer is going to be unrealistic because the 27 billion, which we calculated in the previous question, is actually bigger than the world's population of 9 billion, 9.5 billion. So pause the video and have a look at the questions here. Good luck with your questions and let me know if you've got any questions during the lesson or after lesson.